Welcome to Educator.com. In today's lesson, we're going to be discussing rational expressions. First, defining what they are, and then talking about how to simplify them. A rational expression is a fraction whose numerator and denominator are polynomials. So we've worked with polynomials previously, talked about simplifying them and multiplying them, and now we're going to talk about when polynomials are part of a fraction. So some examples of rational expressions would be x plus 4 divided by 3x minus 2. So you see here what you have is a quotient, just like with any other fraction. Or 6 minus 3x squared over 5x plus 3. And they could be more complicated or less complicated, but this is the idea with what a rational expression is defined as. Because these are fractions, we have to address the issue of making sure that the denominator does not equal 0. Recall that if you have a situation such as 5 divided by 0, that would just be undefined. So that is something that is not allowable. And the same situation exists here because, again, we have a fraction and we have to make sure that we're not dividing by 0. So right here I can see, okay, this is saying divided by 0, that's not allowed, that's undefined. But if I were to say 5 divided by x, I don't know what x is. And if x were to be 0, the result is that this expression would be undefined. Therefore, when we talk about rational expressions, we discuss excluded values. And an excluded value of a rational expression is a value of a variable that makes the denominator equal to 0. In this situation, 5 divided by x, an excluded value would be x equal to 0. So we're saying that's a value that we cannot use for x when we're working with this expression. So this is a very simple situation. Most rational expressions have some excluded values. There can be situations where the expression is such that you won't end up with an excluded value. But there usually are some values for the variables, and there can be one or more variables. There's usually one or more values for the variables that are excluded when you're dealing with a rational expression. So let's look at some examples. Given the rational expression x squared plus 4 over x minus 3. I want to find the excluded values. I don't even need to worry about the numerator because the excluded values have to do with the denominator ending up 0. So if this entire expression comes out to 0, then I've got a problem. Now, how do I figure out what the excluded values are? Well, as I just said, the idea is that the denominator cannot equal 0. Therefore, if x minus 3 equals 0, then it's an excluded value. So what I need to do is solve for x. What you do is you set the denominator equal to 0 and then solve for x in order to find an excluded value. And you can easily check this. If I were to put 3 back into the denominator, well, 3 minus 3 is 0, so I can see that x is indeed an excluded value. It's a value for x that would cause the denominator to be 0, which would make this entire expression undefined. So sometimes it can be a little bit more complicated. Let's say I have another example where x plus 4 can take some more work to find the excluded values in certain cases. So here I have x plus 4 divided by a trinomial. Well, again, I need to figure out the excluded values, so I'm just going to take this entire trinomial and set it equal to 0, and I need to solve for x. And looking at this, the easiest way to solve for x is going to be to factor it out. And it's going to look something like this. And I know that I've got both positives here, so I'm going to have a positive here and a positive here. Now, I need to find some factors of 18, and those would be 1 and 18. Let's see, 2 and 9, and 3 and 6. And I need to find factors of 18 whose sum is 9. That's going to give me the correct factorization. So the product of these two is 18, but I need to find ones who also add up to 9. This is not correct. That's going to be 19. That's 11. Well, the sum of 6 and 3 is 9, so this is my correct set of values. So I'm going to factor this as follows. Now I'm going to use the zero product property. The zero product property, recall, tells me that if the product of two expressions here, or terms, the product of two terms is 0, then each one or both of these must be equal to 0. So I'm going to go ahead and set each of those equal to 0. Because if either one of these expressions turns out to be 0, then this whole thing is 0. When I solve for x, I get x equals -3. And when I solve x plus 6 equals 0, I'm going to get x equals -6. So my excluded values are x equals -3 and x equals -6. Those are excluded values. So if I go back to the original equation and I put -3 in here for x, that would be -3 times -3 is 9. 9 times -3 is -27. -27 plus 9, I would end up with -18 plus 18, so this would come out to 0. That's why this is an excluded value, and you could do the same for -6. So to sum up, an excluded value is a value of a variable in a rational expression that would make the denominator equal to 0, which would cause you to have an undefined expression. So those values for those variables must be excluded when we're working with the rational expression. Now, in order to simplify a rational expression, you approach it by eliminating the greatest common factor of the numerator and the denominator. And this is no different than when you've been working with fractions previously that just involve regular numbers. For example, if I look at 4 over 12, that quotient, that fraction, I see that it's not in simplest form. And the reason is because there's a common factor between the numerator and the denominator. You can rewrite this as 4 times 1 over 4 times 3. And you see that there's a common factor of 4. So that's the greatest common factor between the numerator and the denominator. I can go ahead and then cancel those out. And I now have the fraction in simplest form because I eliminated the greatest common factor from both the numerator and the denominator, the greatest common factor between those two. Now, we need to do the same here with rational expressions. Given the rational expression x plus 2 divided by x squared minus 4, I want to simplify this. So if I were to try to simplify, I need to figure out what the factors are first. That's the only way I'm going to be able to eliminate those. So the first thing to do is factor. You can't start crossing things out because these are terms that are added together or subtracted, and you can't cross those out. You can only cancel out factors. So we're going to go ahead and factor this. And I see I have a difference of 2 squares, so that's pretty easy to factor. It's x plus 2, x minus 2. Now that I have it in factored form, I can look and see that this expression, x plus 2, is the same as x plus 2 down here as one of the factors below. And you really need to look at it as this means x plus 2 times 1. Because if I just said x plus 2 and crossed it out and thought nothing was there, I might put 0 and this whole expression will turn into 0, which is not correct. So this really means x plus 2 times 1. You have to remember that that 1 is there, even if it's not written out. Okay, once I've gone this far, I've done the hard work. Now I just need to cancel out that common factor in the numerator and the denominator. And this is going to give me 1 over x minus 2. Okay. So again, factor first, then cancel out. So I had x plus 2 over x squared minus 4, factored out the denominator, found the common factor, and this left me with 1 over x minus 2. Now, let's talk about what happens when you are simplifying and you're looking for excluded values. The excluded values are values in the original rational expression, not the simplified version. And there's a very good reason for this. If you just go to the simplified version and try to find excluded values, you may not find all of the values because of the canceling out that occurs with simplification. So let's talk about the example that I just did, where I said I had x plus 2 divided by x squared minus 4. So let's go ahead and just review the steps that I took to simplify that. If I said to simplify, remember I first factored. And then I canceled out the common factors. So rewriting this and just remembering that there's a 1 there. You don't always have to write that out, but that's something to just remember. Okay, you're going to go ahead and cancel out the x plus 2's, and you're going to be left with 1 over x minus 2. Now, let's say I said to find the excluded values. When I say to find them in the original rational expression, that means before canceling out has occurred. So I look up here, and the excluded values are going to be those values wherein x squared minus 4 equals 0. What I need to do then is factor this out. Fortunately, I've already done that. So I've done the factoring here, so I can just go ahead and say x plus 2 times x minus 2 equals 0. And then I'm going to solve for, using the zero product property, I'm going to solve for x plus 2 equals 0, x minus 2 equals 0. Therefore, x equals negative 2 and x equals 2. These are my two excluded values. If x were to be negative 2, well, negative 2 squared is 4, minus 4 is 0. If x is 2, 2 squared is 4, minus 4 is 0. Those are both excluded values. Now, look what would have happened if I just came down here and said, okay, I'm going to work with this. It's simplified. I'm just going to find my excluded values using that denominator. Then I would have said, okay, x minus 2 equals 0. X equals 2 is an excluded value. What happened is I lost my other excluded value, and I lost it at this step because I canceled out the x plus 2 in the denominator. And the x plus 2 in the denominator is what gave me my second excluded value of x equals negative 2. Therefore, the rule is that when you're finding excluded values, you always have to go back to the original rational expression. You go back to that denominator. You do not use the simplified form. And we're going to see that in the examples. Okay, our first example asks us to find the excluded values. So again, with excluded values, I'm looking for those values of x such that the denominator would be equal to 0. So what I need to find is situations where the denominator would be equal to 0. What is the x value in those situations? Those are excluded values for x. Well, I need to solve this out by factoring. And I see here that what I have is negative here, which means that this must be the product of a positive number and a negative number. In order to determine what these two values are, I'm going to find factors of 12 that add up to negative 1. The middle term here is negative 1. So factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And I remember that one is going to be positive, one is going to be negative. So what is a situation where I would have a set of factors of 12, one positive, one negative, that would sum up to -1? Well, I can see that either way I do it, making this or this negative, either one, they're too far apart. They're not going to add up to -1. Same here. I'm going to end up with either 6 minus 2 is 4 or 2 minus 6 is -4. I look here, and if I make 4 negative, I would end up with 3 minus 4, which is -1. So this is my correct set of values. So here I have x plus 3, x minus 4. Using the zero product property, that gives me x plus 3 equals 0, and x minus 4 equals 0. Subtracting a 3 from both sides gives me a -3. Adding a 4 to both sides gives me a 4. So excluded values for this rational expression are x equals -3 and x equals 4. Because in either of those situations, the denominator would end up being equal to 0. Okay, in this second example, I need to both simplify and find the excluded values of this expression. So rewriting it just below, what I need to do is simplify by pulling out the greatest common factor, and you can do a lot of this in your head and cross out, but at first it's sometimes good to write it out. Just be very careful, make sure you haven't missed anything. And if I'm looking first at the greatest common factor of the numbers, the greatest common factor of 6 and 16, well, those have a common factor of 2. The greatest common factor of the x's, well, the largest power that one of the variables is raised to in both the numerator and the denominator would be 3. Actually, saying that slightly differently. X to the third is smaller, and so that's found both in the numerator and the denominator. X to the third is a factor of x to the sixth. So that is part of my greatest common factor. Y squared is a common factor for both the numerator and the denominator. And z. A z is found in both the numerator and in the denominator. So I could rewrite this as the product of its greatest common factor and what remains when I pull that out. So if I factor 2 out from 6, I'm going to get 3. My x3 is gone. It's here, part of this greatest common factor. Y squared, that's been pulled out, and a z has been pulled out, leaving behind z cubed. In the denominator, I'm going to have, again, my greatest common factor. I'm going to see what's left behind. Well, factoring a 2 out of 16 leaves an 8. Factoring an x cubed from x to the 6th leaves behind x to the 3rd. Taking a y squared out of y cubed leaves me a y, and the z is gone. Okay, so now I just cancel those out, and what I'm left with is 3z cubed, 8x cubed y. So this is my simplified form, and I was asked to simplify and find the excluded values. So again, I just want to point out, you can always pull out the greatest common factor and then cancel that, or you can start just canceling out up here one term at a time. That I know that 2 is a factor of 6, so that would leave me 3. I just start dividing. I'm left with 8. Right here, this is going to cancel out completely, and this is going to become x cubed, and I can go on like that. And that's how we'll do it in some later examples. Anyways, now I need to find the excluded values. So here is the simplified expression. That's what I was asked to do, is simplify. The next thing I'm asked to do is find the excluded values. So let's do that. Excluded values will occur when the denominator of the original expression, do not just go down here. I mean, by the time I get to here, I'm missing a variable, and I actually have to address all of the variables. I need to find values for any variable that would cause this expression to equal 0. And because of the canceling out, I'm missing a variable down here at this point. That's why you can't work with this simplified expression. Working with the original denominator, I'm going to look for situations when this entire product equals 0. So let's just divide both sides by 16 to just get rid of the 16 over here. So divide both sides by 16, and that's going to become x to the 6th, y to the 3rd, z equals 0. So just looking at this, I can see that if x is 0, this whole thing will be 0, because 0 to the 6th is 0. If y is 0, then y cubed will be 0, and that's going to make this whole product 0. If z is 0, the entire product will be 0. So I could, sit down and write each one and then figure it out, or you can just look at it and say, okay, what would be values of x in this situation, x, y, and z, that would cause the entire expression to be 0? And from looking at that and just thinking it out, I determined that if x is 0, y is 0, or z is 0, then the denominator will be 0, so these are my excluded values. And I found them for each variable in the denominator. So again, simplifying by canceling out the greatest common factor, which I did, and finding the excluded values by going back to the original expression and setting the denominator equal to 0 and determining that if x is 0, y is 0, or z is 0, all of those are excluded values, all three. In this example, we're asked to simplify and find the excluded values. So when you're simplifying, you need to factor out both the numerator and the denominator and cancel out the greatest common factor. So therefore, let's factor out the numerator. And I see that I have a common factor of 4, which is going to give me y minus 6. And in the denominator, I have a common factor of 2. That's going to give me y squared minus 4y minus 12. Okay, I need to factor this trinomial. I'm done factoring the numerator. In the denominator, I've got the 2, and I've got y. Got two binomials. Since I have a negative here, this is going to be y plus a number and y minus a number. To figure out what that number is, I'm going to take factors of 12. 1 and 12, 2 and 6, and 3 and 4. Well, these are factors of 12 that need to add up to negative 4. And I know that one of the numbers will be negative and one will be positive. So when one of these is negative and one is positive and I add them up, which one of these will give me negative 4? Well, I can see that either way I do it here, I'm not going to get 4. So I go to the next one. If I take negative 2 and 6, that's going to give me a positive 4 if I add those. So that's not correct. Let's try 2 and negative 6. Well, 2 minus 6 does equal negative 4, so this is the correct set of factors. Okay, so I'm going to go ahead and factor according to what I just determined here, and that is y plus 2, y minus 4. I now have everything factored out. Once I've factored, I can start canceling. Actually, that should be a 6 right here. Correction. Okay, so that is a 6. My two factors are 2 and negative 6. So I have a 2 here and a negative 6 here. Now you can start canceling out, seeing that y minus 6 is a factor in the numerator that is also present in the denominator. So those cancel. I also have a common factor over here of 2. That becomes 1, and I end up with 2 in the numerator. Now, let's see what I've left. In the numerator, all I have left is a 2. In the denominator, I have y plus 2. So this is my simplified expression, is 2 over y plus 2. Now, for excluded values, what I'm going to do is go back to my original expression and say, okay, 2y squared minus 8y minus 24 equals 0. In order to solve this, I need to factor it out. Fortunately, I've already factored because I was simplifying. So if you look at what I did to the denominator, I factored it right here. I can use this. There's no need to redo the work. I haven't done any. I need to take the factored expression before anything's canceled, and I can use that. So all this is the factored form of this trinomial. I'm going to divide, or I'm going to go ahead then and use the zero product property after dividing both sides by 2. So I'll just end up with y plus 2, y minus 6 equals 0. And this is going to give me y plus 2 equals 0 and y minus 6 equals 0. That's easily solved to give me y equals negative 2 and y equals 6. So my excluded values are y equals negative 2 and y equals 6. And if I would have used the simplified form, I would have only ended up with the excluded value y equals negative 2 because my y minus 6 would have dropped out. So that's why it's important to go back to that original expression. So this is simplified form and the excluded values. Okay, again, simplify and find the excluded values. And this one is more complex. It requires some factoring in the numerator and denominator. Always pull out the greatest common factor first before you start factoring the trinomials so you don't have to work with numbers that are as large. So I do have a common factor of 3 in the numerator, which is going to leave me with z squared plus z minus 30. Denominator, same thing. I have a common factor of 4. So that's going to leave me with 2z squared plus 9z minus 18. Factoring. So the numerator has a leading coefficient of 1, so that one's a little bit simpler to factor. And I know that I have a negative here, so it's going to be z minus something times z plus something. And if I look up here at factors of 30, I've got 1 and 30, 2 and 15, 3 and 10, 5 and 6. And I want them to add up if one is negative and the other positive. These need to add up to just 1. That means I'm going to look for factors that are close together. So that knocks this out and this. These aren't really that close together. Let's look at 5 and 6. So if I have a negative 5 and a positive 6, and I add those together, negative 5 plus 6 equals 1, which is the middle term. So the correct factorization of this would be that I have z minus 5, z plus 6. The denominator is tougher because the leading coefficient is not 1, but I know that what I'm going to end up with is 2z and then a z here, so that I get 2z squared when I multiply my first terms. I also know that I have a negative here, which means that this is going to be positive and I'm going to have a negative sign over here, or the other way around. Doesn't matter. Okay, so what I need are some factors of 18. So let's start out with that. I know that I need some factors of 18. But it's a bit more complicated because I have a 2 here that's also going to be multiplied. So the factors of 18 are 1 and 18, 2 and 9, and 3 and 6. Now let me look at what I have up here. I end up with a 9z. That's not a very large number considering that there's a 2 involved. So I'm going to be multiplying this 2z times this outer term. And if this was a large number, then I'm going to get a large number here. And I'm going to probably end up with something bigger than 9z. So I'm going to start out with numbers that aren't that large. And the easiest one to work with is actually 3 and 6. And I'm just going to use trial and error. So 2z plus 3, and then I have z minus 6. So the first term I'm not worried about. I want to look at the outer plus the inner because that will give me my middle term of 9z. So the outer would give me negative 12z, and the inner would give me 3z, which would be negative 9z. Well, I know I'm on the right track. I just need to instead make the 3 a negative and the 6 a positive, and then I'll get a positive 9z. Okay, so I'm going to go ahead and make the larger number, which is 6, a positive, and the 3 a negative. And you can always double check this by multiplying it out to see that you get 2z squared. And then you're going to, actually this one, change this around just a bit. I'm going to still have the 2z with the 3, but this is going to be a negative. That's why it's a good idea to always double check the factoring in a complicated situation like this. This is going to give me, let's see, an outer term of 2z cubed, and then 12z. That's 2z times 6, negative 3z, minus 18 when I multiply out the last term. So that's 2z squared plus 9z minus 18. Okay, that's what I started with. That's what I had when I factored. So I'm set there. This is the hardest part, doing all the factoring. Now, what I need to do is look for common factors. 3 and 4, no common factors. You can't really cancel out there. Z minus 5, not a common factor, nor is 2z minus 3. But I do have z plus 6 as a common factor, so I'm going to go ahead and cancel those out. And that's going to leave me with 3 times z minus 5 over 4 times 2z minus 3. So this is my simplified form. Now, finding the excluded values. Again, I'm going to go back up to the original. And I'm going to look at the denominator. And what I want to do is set this denominator equal to 0 and solve for z. In order to solve for z, I need to factor. And fortunately, I've already done that because that was quite a bit of work. So I just want to go ahead and look at what I've already factored. I pulled out a greatest common factor of 4 from the trinomial, and then I factored the trinomial into this. So that's going to give me 4 times 2z minus 3 times z plus 6 equals 0. Divide both sides by 4 to get 2z minus 3 times z plus 6 equals 0. Using the zero product property, I'm just going to go ahead and set 2z minus 3 equals 0 and z plus 6 equals 0. Okay. Let's solve for each of these down here where there's a little more room. So first, 2z minus 3 equals 0 is going to give me 2z equals 3 by adding 3 to both sides. Next, I'm going to divide both sides by 2 to get z equals 3 halves. For z plus 6 equals 0, I'm going to subtract 6 from both sides to get z equals negative 6. So these are my two excluded values. Okay? Z equals 3 halves and z equals negative 6. Those are excluded values. Simplified form is right here. And this was, as I said, pretty complicated. A lot of factoring involved, pulling out the greatest common factor, and then factoring the numerator and the denominator, canceling out to get my simplified form, and then going back and taking this original trinomial, setting it equal to 0, writing it in factored form, which I already had, and then using the zero product property to find those two excluded values. Thanks for visiting educator.com. I'll see you next time.